is Xiaowei, and I'm an associate professor from Department of Engineering in the Reitaku. And I'm honored to have the opportunity to make my presentation here. The title of my presentation is Artificial Intelligence in Software Engineering, Integration and the Key Challenges. Okay, so of course, nowadays we are using various of software. Initially, when when the computer machine, appears, so first it comes to mathematical computations, and then it's associated with intellectual applications. And nowadays, we have various of softwares like the operation systems, like Windows, Linux, and Mac OS. And based on this, we have a lot of tools like Office, email, and instant messaging tools. And also, a large number of websites has been built. In addition to that, there are various of entertainment such as, YouTube or Netflix for the video playing, audio, and also many games. In addition to that, social networking is also a very important part of the software. As we can see, the software plays a more and more important role in our daily life, and I believe the trend will continue. And we can, especially with the cyber society, appearance of cyber society, the software may play more important role in the future. And as for the Japanese software industry, although Japanese is a developed country, but its software industry is not well developed. Based on the previous studies, the Japanese, the software industry in Japan is not so, most of it belongs to the outsourced. They employ, they will send this task to some other countries or to some other companies to finish the software development. So in fact, in its own IT industry, the software is not very strong. And especially in the global market, excluding games, the proportion of Japanese-made consumer and industry software is quite low. And as we know, there are quite a lot of issues in software development. So first, we always start from the requirements management. In large-scale software projects, requirements are often complex and involve many, involve many engineers. Inadequate management can lead to frequent changes and ambiguity or misunderstanding of requirements, impacting the final product's quality and usability. In addition to that, the scale and the complexity of the project is also an issue. Large software projects also involve extensive code and many modules requiring a good design and efficient module and division. So the scale and the compatibility make coordinating the team effort and maintaining the software quality and ensuring their code maintainability more challenging. Also, there's always an issue for team cooperation and communication. Large projects usually involve a number of people, so it requires the collaboration across multiple teams and with diverse backgrounds and specialized skills. We can always see a lot of, this kind of communication issues, such as misunderstanding about the requirements or about the boundary of each team's responsibility, and cause some delays or even the quality issues. In addition to this, there's also, other issues such as quality assurance and testing. Usually, when we finish the coding, we need to prepare a large number of test cases and trying to cover all the processing flow of the code. But usually, it's very labor intensive, and a full test is extremely quite challenging. So the automating and maintaining test is also quite a significant challenge. And meanwhile, the project is, there usually the time and cost management for the projects. It's also, it always comes with strict timelines and budget constraints. Delays and cost overruns are common, often due to inaccurate estimate of poor management or external factors. Finally, it's about the document update and maintenance. As we are writing the code, in fact, the document is a really an important issue because usually the teams rely on the document to communicate and to, let's say, to reach consistency about the what we need to do. But usually, I mean, this kind of document is not fixed. I mean, usually we always face, I mean, a large number I mean, requirement changes. So the document need to be updated from time to time. But usually, programmers do not like to, I mean, finish this task because it's boring and it's always changing. So to keep the document updated in a right, I mean, keep the document updated and timely. So it's quite a, I mean, a boring issue for programmers. So therefore, sometimes it's cause, I mean, bad result in the project management. So in software engineering, I mean, the essential code and the essential part is the art of managing millions of lines of code. I mean, for instance, in 2001, the released version of Red Hat Linux contains 30 million lines of source code. It looks a little bit incredible, but it's the truth. Even, I mean, considering its core, I mean, the Linux core, the size of the code is still, I mean, about 2.4 million lines. So in the software development, usually it requires several different, I mean, parts. So first, we need to do the requirement analysis, and then we need to, let's say, do the system design. We need to build the system architecture, analyze the bottleneck and the resource we need. And then we need to implement the code, I mean, based on a team of engineers. And then we need to deploy and test it in the real environment. And finally, we will release it. And the following, I mean, maintains work. There are a lot of, I mean, development models such as, let's say, waterfall model, increment model, spiral model, and agile development. But still, I mean, there's a no model which can, let's say, management software in a perfect way. There's always, I mean, a lot of issues, this or that. I mean, based on different models, the problem may be different, but still, I mean, manage a large team, manage a large software project is still quite challenging. So, I mean, in fact, the software development has been, let's say, has been here for more than, let's say, dozens of years. As we can see, as I start to, I mean, learn programming, we start using Tuple C, yeah. And now, I mean, nowadays we are using more advanced IDEs such as Visual Studio. Let's say the interface looks a little bit different, but the core is almost the same. As we can see, even in the latest, I mean, even in TubeC 2.0, we almost have all the functions we needed for debugging, debugging a program. But nowadays, I mean, its latest version, such as the Visual Studio, curtains more functions. I mean, curtain more functions such, I mean, when we are trying to write the code completion, the debug, the syntax checking is more convenient and yeah, it really saves time. But still, software development primarily relies on human efforts. We still, I mean, about 2 years ago, we still need to write the line one by one by the engineers. So although, I mean, it's more convenient, but the core task for software is almost the same. I mean, if it, I mean, it's almost the same. But there are some, I mean, researchers trying to integrate AI with software engineering. There are some early attempts. Previously, it's mainly based on modules such as RNN and LSTM. And I mean, if we are trying to apply this kind of techniques to code generation, often it is combined with the structured code representation, such as the abstract syntax trees. But this kind of early attempts lacks of accuracy and robustness. Often there are a lot of errors in the general code, and yeah, almost. I mean, it doesn't attract much attention among the world. I mean, from the world side. But 2 years ago, I mean, since the breakthrough success of the ChatGPT 3.5 architecture, I mean, now it becomes, possible for integrating AI with with the software engineering. Uh, Thanks to the powerful language model abilities, this kind of AI can understand the requirements which are represented by the natural language. And also, because they have I mean, very powerful. They are short and a few short learning abilities. So by providing some samples, I mean, this kind of coding samples, they can learn it fast. Uh, I mean, because I mean nowadays they have tons of sample code from the GitHub, from the Stack Overflow. So nowadays this kind of a large language model has learned strong ability for the coding. Uh, also, you can see a lot of I mean, available large language models such as ChatGPT-4, Llama, DeepSeek, and even the latest release, the Grok 3. I mean, this kind of models are very strong for code generation. Yeah, as we can see, I mean, here is an example of the, let's say, the latest tools for code generation. One is the Google Colab. As we can see in the left figure, when you, I mean, you can try to, I mean, when you are trying to write some Python code, you can use Google Colab. And here is, let's say, generated by AI. When you write your requirement here, such as write a function to get the local time, print it out and convert it into int, a universal time, and then it will automatically generate the code in the, I mean, in the, let's say, code block, I mean, below, and then you can run it. And as we can see, you can see the, as we can see, you can see the result. Yeah, it's, I mean, the code generation is a little bit, I mean, seems perfect. It's, let's say, print the local time, and also we get a int timestamp, I mean, for this, I mean, for the requirement. It looks perfect. And similarly, I asked the similar question to ChatGPT-4, and it can generate the, I mean, output in its chat box. I mean, as we can see, you can see the result, I mean, the code here, and also you can see its output here. And it's also nice. Previously, ChatGPT-4 have a code working, I mean, had a code working space. You can run your code there, but now I cannot find it. Maybe ChatGPT has removed this function. Another, I mean, very famous tool is the cursor. Yeah, it's really, really convenient. It means, I mean, but it embedded the, let's say, the AI tool with the Visual Studio code. I mean, interface like Visual Studio, and then you can write your requirement in the chat box here, and then it will automatically fix the code in, I mean, in the editor. So it is really convenient. There's no need to copy and paste the code. I mean, to switch from your window and between to switch between your window and the chat box. So it is really convenient. But meanwhile, the I mean, essential function, the code generation is supported by large language models. So in fact, the performance might be similar. I mean, if we compare with other, I mean, large language model-based chatbox. So now let's talk about some key challenges in the software development. Here is, I mean, working flow when we are trying to develop a software. So we start with some, I mean, with the requirement analysis. Like, I mean, let's say we discuss about what we need to do, and we generate some document to describe the requirement. And then we have system design. We may use a different kind of tools such as UML to build this, I mean, to build the system design. And then the engineers, we are trying to, I mean, start the code implementation and also write the related document. And then we will try to deploy and testing it. I mean, if we found bugs or we needed to, let's say, implement more functions, then we will begin the loop again. So I mean, this is a very common, I mean, loops for the software development. So the first is the requirement, I mean, generating the requirement list. Uh, when we consider what AI can do here, in fact, in fact, AI need to play, I mean, quite a lot of roles in this task. First, I mean, this usually the discussion or documents is represented by, I mean, is recorded using natural language. So first, AI need to understand what's going on. I mean, it is not written in mathematical language or programming language. It's written in natural language. So after understanding it, AI need to extract the key requirements and also identify the, and also trying to identify the performance specifications. And then after that, maybe the AI may found some kind of ambiguous statement, like what do you mean by this? I mean, do you mean okay? I mean, do you mean by implementing the code in this way or not? Maybe he will find some point like this. So we need to let's say communicate with human engineers to further, I mean, make this kind of requirement clear. So this is requirement, I mean, generate the requirement list. Second is about system design. Usually this work is done by, let's say, by experienced human engineers. I also tried a lot of AI tools. I found AI is quite good for generating some kind of classes. They can, they already learned tons of code. So some of the code is written well. So you can ask it to do this kind of architecture design. Although you cannot fully to let the AI to build a large system, but you can ask AI to assist in this part. And also, we can ask AI to try to analyze the potential risks and contradictions, such as what's the possible bottleneck of this system, or what's the possible reliability issue in the system. So, AI may provide with you, with this kind of feedback. So based on this kind of assistance and the feedback, maybe we can build the system architecture in a more efficient and stable way. And then after, let's say, build the overall framework or design, we need to implement the code for the, let's say, for the module based. Usually we develop the code, in a module level, one by one. So the automatic code generation, currently, the AI is quite good for implementing function level. If you can write down a very detailed description about the function, and in fact, we can see that AI may complete it quite well. And in fact, the ability of AI is also, advancing very fast. Last July, when I tried to test the human evaluation code coding data set, most of the AI is not working very well. But nowadays, if you are trying to still test the data set like that, you can find many AI such as the GPT-4 or the Grok 3 can do it quite well. And in addition to that, we hope the AI can help us for the code review. Sometimes the code is not generated by AI, but existing code from the human engineers. We hope the AI can check the existing code to find out whether there are some problems inside. And also, after writing it, we need to generate related explanation and code. I found AI is extremely good for this task. Yeah, we can ask AI to generate the code explanation or generate the documentation. Yeah, it's very powerful. And usually they can do this task very well. Most of the generated document is quite good. The last part involves test and deployment. As for the test, first we need to, let's say, ask AI to generate a lot of test cases. Frankly speaking, the AI currently is not so good at this, but I believe based on some guide from the human engineers, maybe it can do it better. And also, we need to automatically deploy it, in the real environment and test it. I think AI can do this task quite well because as for the human developers, sometimes we always miss this thing or miss one point or miss just one step. So it may cause various problems in the deployment. But I believe AI can check this quite well and do a perfect task for this. And finally, is we need to, let's say, debug and diagnose various programs. In fact, AI currently is still far from this object. Because to do so, AI need to, let's say, get the various information from the system, such as output or sometimes some visualized interface or some interactions. Currently, this kind of support is insufficient. We can see some advances in these aspects, but currently is still insufficient. So there are some key challenges, and opportunities in this field. Maybe in the future, we just instruct the AI, please write a software for me, please write an email software, or just write office software for me. Maybe after waiting several hours or several days, it can fully automatically, produce it. But now it's still a little bit far from this object. And so, based on the current status of the AI, in fact, the programming, there's a kind of, it provides a large opportunity for us. Meanwhile, the great challenges also exist. The first is, the programming, in fact, demands extreme precision. A minor but fatal error, such as a memory allocation fault or formatting mistake, may lead to the collapse of the entire software system. As far as we know, in the last July, there's a, worldwide, blue screen issue. Yeah, happened. In fact, it's just due to a minor error, but it's caused a great, very, very bad, subsequences in the worldwide. Currently, oh, okay, thanks for the reminder. Currently, AI cannot handle large-scale software projects. And the first is a development agent. We needed to write some module code. So it involves the functionality and the conformance to the specifications and the reliability and issues like this, just as I mentioned for the module level automated code generation. Second part is about the core agent. We also need a system level, this kind of agent to coordinate different, the agent, the code generation agent. It involves several important tasks such as the task decomposition. It need to be able to do some kind of reasoning to considering the subtask creation, validation, and also it need to optimize the system and providing feedback. Meanwhile, it also need to, let's say, coordinate the work, from the multiple agents, such as construction, the workflow, and the designs, cooperative framework like that. Another additional work is about the knowledge management agent. In fact, there are various external knowledge, when we develop a system, such as rules, regulations, specifications, or the specialized knowledges about this industry. So there's a lot of external knowledge. Usually, currently we are using two kind of methods. One is retrieval augmented generation, such we call the RAG, and another is fine tuning. Both way has some issues, but currently many researchers are working on this issue, and there's a lot of, recent advances like, Microsoft's, GraphRag like that. Yeah. And also, as for the AI integration, there are many, project management issues such as automatic file document injection and updating, and also document retrieval and access. In addition, we need to acquire information from the system, and also we need various output such as we need to simulate the keyboard and mouse actions. So, Microsoft just released its latest, tool that's called OmniParser. That's one of this kind of automated tool. And also, we also need to get, debug information from our system, and also we need to cooperate with the human engineers. So there are still quite a lot of challenges with the inside. So this is a very brief introduction of this, my work. Thank you very much for your attention. Any questions?